Welcome to our second lesson on solving systems of equations. You learned in our first lesson that a system consists of two or more linear equations with the same variable. Doesn't matter what the variable is as long as they are, the same. So lesson 5.2 in the 8th grade book, page 210, we're going to solve a system of linear equations, and this time we are going to do it using something called substitution. How can you use substitution to solve a system of linear equations? I'm going to tell you. So you need to write down solving a system of linear equations. Here are the steps. You can get them from the book. We read them in class. One, you solve one of the equations for one of the variables. In other words, you can solve either equation for y or for x. You're used to solving for y. That might be a good way to go. Step 2, you substitute that expression from step 1 into the other equation and solve for the other variable. Now this will make more sense as we actually do some examples. And then number 3, you take the answer from number 2, put it into the original equation, and solve for the first variable. So let's do it. Solving a system of linear equations by substitution. So the first thing it says to do is take either equation and solve for either variable. Well, it just so happens in this one, we have y equals a negative x minus 5 and y equals a negative x minus 6. Well, they're already solved for one. In fact, both of them are solved for y. So I'm going to take one of them. I'm going to take the second one. I'm going to take this negative 2x minus 6 and I'm going to substitute it into the first equation, and I'm substituting that expression for y. So this is what it would look like. Negative 2x minus 6 equals this equation here, negative x minus 5. We have solved these before in our unit 3. And now we're going to solve for x. Well, how do we do that? We combine the variables on one side. I like to have mine positive, so I'm going to add 2x to both sides. That gives me negative 6 equals, well, a negative x plus 2x is just x minus 5. Now I'm going to continue by isolating the variable. Now that I've combined them, I've simplified it. I'm going to isolate by adding 5 to both sides to keep it balanced as I isolate. And negative 6 plus 5 is negative 1 is equal to x. So now we know that the solution to a system of linear equations is an ordered pair. So I can come over here with my answer, my ordered pair answer, and I know that x is now negative 1. The third step says, now take that answer, substitute it into one of the original equations. So I'm going to take this negative 1, and I'm going to substitute it into this one right here. And I'm going to solve. So right here, I'm going to say y is equal to a negative, because that's a negative x. And well, x is negative 1, so I've got to put a negative 1, and then minus 5. And well, a negative 1 is positive 1. Minus 5 is negative 4. So my y equals negative 4. Okay? Well, since I put that into the top equation, I can double check this solution in the bottom equation and substitute into that bottom equation y equals negative 2x minus 6. I'm going to substitute in negative 1 for x and negative 4 for y. So negative 4 now equals a negative 2 times negative 1 minus 6. Negative 2 times negative 1 is positive 2. Positive 2 minus 6 is negative 4. So negative 4 equals negative 4. Voila. It's good. The ordered pair solution, negative 1, negative 4, is the answer. You could graph that if you wanted. We're not going to take the time today. Graphing would be another method, right? Because substitution is a second method. So let's do that again. This time, we look at the two equations that make the system, and only one of them is solved. Only one of them is solved for y. So now we're going to take that and we're going to substitute in for y right here. And this is what we have. Negative 2x minus 3 times y is that entire expression, 6x minus 11. And we know that equals negative 7. Now we use the distributive property to simplify. A negative 3 times 6x is negative 18x. A negative 3 times a negative 11 is a positive 33. And the negative 2x just comes down, and it still equals negative 7. I'm going to combine these two like terms. They're on the same side. I just combine them using the operations given in front. This is a negative and this is a negative. So when I add them up, I have a negative 20x plus 33 is equal to negative 7. I want to isolate x. So what am I going to do? Subtract 33 from both sides. Negative 20x is now equal to negative 40. Divide that by negative 20, and x is equal to 2. Now I'm hoping that you are just listening at first, and once I'm done with this entire example, you then copy down what we did. So I come over here, my final answer, my x is 2. And so I'm going to take that 2, and I'm going to substitute it into one of the originals. Let's just go right here. And I'm going to say y equals 6 times 2 minus 11. 6 times 2 is 12, minus 11, 1. Y equals 1. My ordered pair answer is 2, 1. I'm going to verify that. I'm going to take those two and put it into the second equation, where negative 2 times 2, because my x right here is 2, minus 3 times 1 equals negative 7. Negative 2 times 2 is negative 4. Minus 3 times 1 is 3. Equals negative 7. Negative 7 equals negative 7. Voila. Again, I had a graph there in case you wanted to graph it. It's just another way to verify. If you want to spend the time graphing, you can. But I can tell you, these don't have compatible numbers. And so it makes it kind of difficult when you're getting the slope and the intercepts to get on there. But it's possible. Let's just continue on with our substitution. Again, we look at the system, and one of them is solved for y. So right here, I take that x minus 1, and I'm going to plug it up in here for y. And when I do that, anyway, when I do that, I have 2x minus 3 times x minus 1, and that equals a negative 1. So I use the distributive property. The 2x comes down. Negative 3 times x is negative 3x. Negative 3 times a negative 1 is a positive 3, and that equals negative 1. Combining like terms, a 2x and a negative 3x is negative x, plus 3 equals a negative 1. Subtracting 3 from both sides, negative x equals a negative 4. My x cannot be negative, so I'm making that positive by dividing out the negative 1, and x is equal to 4. I come to over here, my x is 4. Now, ladies and gentlemen, I've been solving for y first all the time and giving me the x answer. You can still go the other way, and we'll do some of those in class. So here we go. I'm going to take that 4, and I'm going to substitute it into the first equation. And I'm going to say 2 times 4 minus 3y equals negative 1. 2 times 4 is 8, minus 3y equals negative 1. I'm going to subtract 8. I'm going to subtract 8. I get negative 3y equals a negative 9. Divide by negative 3. Y equals 3. 4, 3 is my answer. I take that. 4, 3, I'm going to substitute it into the second equation. So 3 equals 4 minus 1. 4 minus 1 is 3. 3 does equal 3. So this is my ordered pair solution. Our last one is negative 4x plus y equals 6 and negative 5x minus y equals 21. Neither one of these is solved for a variable. So this one we're going to just We're going to solve the, one of them for, well, the easiest thing to do is to solve for y because there's no coefficient on y. So all I have to do is move this 4x over. I can say y equals 4x plus 6. Now I can take that and substitute it in here for y. And then what would I have? I would have negative 5x minus my parentheses. I'm going to put in there 4x plus 6. And then I would say that that is equal to 21. Distributive property would be a negative 5x minus 4x minus 6 equals 21. Combining these two, a negative 9x is equal to, well, we'll just do that. Negative 9x equals, because I'm going to add the 6 to both sides, 27 divided by a negative 9, x equals negative 3. So in my ordered pair answer, x is negative 3. I substitute that negative 3 into the original equation. I have negative 4 times negative 3. I have plus y equals 6. Negative 4 times a negative 3 is 12. Plus y equals a negative 6, equals 6. Subtract the 12. I think I was jumping the gun there. Y equals negative 6. I can take that ordered pair and verify my answer by going to the second equation and saying negative 5 times a negative 3 minus a negative 6 equals 21. Negative 5 times negative 3 is 15. Minus a negative 6, that's actually same change plus 6. 15 plus 6 is 21. So 21 does equal 21. Negative 3, negative 6 is the ordered pair answer to this system. Ladies and gentlemen, your quick write. One system to do. Please write it down. Y equals 5x minus 7. Negative 3x minus 2y equals a negative 12. Go ahead and solve that system. Take a quick break. Come back and see me.